Okay, everybody, here we go. This one's going to be a little bit more involved. Sketch the following linear functions on the grid provided. I'm going to do all of these. So if you want to kind of skip ahead to one of these things because you're not sure, you're just going to have to fast forward here. First of all, x plus 5 equals 0. If I isolate the x, I get that x is equal to negative 5. So this is referring to a set of points, because every line is essentially a set of points, where x is equal to negative 5. Now that means coming over here, okay, on our graph here, x equals negative 5 is right here. Every point along that vertical line has that as an x coordinate. I'll try to make this a little darker. So this is going to be a vertical line, okay, through negative 5. So right here, this is the answer to A. Y minus 7 is equal to 0. Let's isolate the y. And in a really a very similar sense here, this is a set of points where the y coordinate is 7. Okay, the y coordinate stays constant. The x can be anything. Now as a result here, what that means here is we take a look at where y is equal to 7 right here. Okay, every point along that horizontal line has exactly the same y coordinate. And so this is the equation, or this is the line that little equation here is trying to describe here. So I'll label that. There's B. Y equals 2x plus 4. Okay, well this is in slope-intercept form. I can see right here that my slope is 2, my y-intercept is 4. So what does that mean over here? Well, my y-intercept is 4 is right here. And a slope of 2. Okay, slope of 2. Let's think about this. Whoops, slope of 2. This is 2 over 1. Rise of 2 over a horizontal motion of 1 here. So starting right here, I'm going to go up 2 over 1. Now, technically speaking, I only need 2 points to graph a line. Practically speaking, that's not true. I need a lot more than that to get this to be somewhat accurate here. So starting here, I'd go up 2 over 1, up 2 over 1. Now, if I've run out going one direction, I can go backwards as long as I move I do everything in reverse. So instead of going up 2, forward 1, I'm going to go down 2, backwards 1. Down 2, backwards 1, and I'll just keep doing this. I'm off the screen already. Just keep doing this until I have a whole bunch of points here. And now what I'll do is connect the dots. Okay, now I'm going to have to go down here. I'm going to have to move my A, because I'm going to get confused by that later on here. Here's my A. This right here is my C. Okay? Now to D. X minus 2y minus 6 is equal to 0. Okay, well there's a couple of things I could do here. I could convert this into a different form of equation. I could put this into slope-intercept form if I wanted to. But you know what? I'm going to show you another way of doing this. I'm going to find the x-intercept. Okay, now at the x-intercept, the y-coordinate is 0, so that term would disappear. And then I'm left with x minus 6 equals 0, and that'll only be true if x is equal to 6. And now I'm going to find the y-intercept, and at the y-intercept, I let x equal to 0, so this term is going to disappear, and I'm left with negative 2y, negative 2y minus 6 equals 0. So bring the 6 over, it'll be negative 2y equals positive 6, and then divide by negative 2, and you're going to get negative 3. Now, once you've got the x-intercept at 6, let's identify that right there, and the y-intercept at negative 3, which is right here, okay, I should be able to just connect those two dots here. Now, what's going to happen here is you can kind of count this out here. You're going to end up with, to get from here to here, you're going to end up with a slope that's essentially 1/2. 1 up 2 over, 1 up 2 over, 1 up 2 over. And so I'm just going to extend that so I get a bunch more points here. Now, to go backwards, I'm going to go 1 down, 2 back, 1 down, 2 back, 1 down, 2 back, and just keep going here. And then once again, just like before, I'm going to connect the dots. And this is my line D. Whoops, D. Okay, good. Keep going here. 3x plus 4y is equal to 32. Okay, now I could do the exact same thing that we just did, and that would be fine here. However, this, when it's in standard form like this, this is really close to slope-intercept form. I might just bring over the 3x, make it negative 3x plus 32, and then divide by that 4 to get y is equal to negative 3/4 x plus 8. Okay? And so now this is going to have a y-intercept of 8, and then a slope, whoops, down here, a slope of negative 3/4, meaning down 3 over 4. So from 8, I'm going to go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. Down 3, 1, 2, 3, over 4, 1, 2, 3, 4. And then I'm not going to be able to kind of sustain that, keep that going for very much further than that, but I've got enough points that I could probably connect this fairly reasonably. It's going to look something like this. Okay, and there's line E. Now finally, the last one that we've got here is in point slope form. So I can see right away that this is going through the point negative 3, negative 1. Now, and remember, every time I grab the point out of there, I'm changing the sign on those numbers there. And it's got a slope of negative 5/3. Whoops. Sorry, you can't see the separation from the negative sign and the equals there. So equals negative 5/3. So the first thing I want to do is identify the point negative 3, negative 1. Okay, so negative 3, negative 1, that's right there. And then a slope of negative 5/3 means down 5, 1, 2, 3, 4, 5 over 3, 1, 2, 3. Down 5, 1, 2, 3, 4, 5, 2, 3. So I'm off the grid a little bit. Now that only gives me a couple, whoops, sorry, you can't see that. Only a couple of points here. Let's go back up to here, and let's work the slope backwards. Because I could move that negative and make this 5 and negative 3. It's the same number. But this means I go up 5, but this time I'm going to go left 3. So from right here, I'll go up 5, 1, 2, 3, 4, 5, and left 3, 1, 2, 3. And I can maybe do that one more time here. 1, 2, 3, 4, 5, 1, 2, 3. Okay, so now I'm going to try to connect these guys in as straight a line as I can. I'm not too worried. If you wanted to use a ruler, by all means, but I just want an approximation there, or as good as I can get here. Come all the way down. This is the answer to F here. So let's zoom out a little bit and have a quick look. That's essentially what this question here should look like.